Gonna wait to see if it's streaming, as always. I'm gonna continue to study this stuff here. Hopefully I can finish today. And it looks like there's a bunch of people using ChatGPT now. So hopefully it doesn't break or it doesn't stop working in the middle. Just want to make sure that it's streaming before I start doing things. It's taken a long time. Maybe I did something wrong. Maybe it's just the internet. Oh, it looks like it is streaming. For some reason, it's not showing up there. Oh, okay. So it doesn't show up here. Maybe they changed this because it was showing up here the previous times. So, but I added a description this time for my Twitter, so maybe that's what changed. And now it only shows up here. Or whatever. I already put a bunch of things here, and I'm gonna start with Redux. And I'm gonna go one by one, I think.
Redux is a popular JavaScript library for managing application state. In Redux,
One by one
can
here.
dispatch an action, which is a plain object that describes the change to the application state. The map dispatch to props function is used to bind the action creators in a Redux application to the dispatch function, which is used to dispatch actions to the store. This allows the action creators to be called directly from the props of a component, rather than having to dispatch the actions manually. Here is an example of map dispatch to props being used to bind action creators to dispatch. Function map dispatch to props, dispatch, return add todo, text, equals dispatch, add todo, text, remove todo, id, equals dispatch, remove todo, id. In this example, the add todo and remove todo action creators are being bound to dispatch, so that they can be called directly from the component's props. For instance, a component could call this.props.addTodo, learn Redux, to dispatch the add todo action with the text value of learn Redux. In Redux, a container is a term used to refer to a React component that is connected to the Redux store. A container component is responsible for subscribing to the store, dispatching actions, and providing the data from the store as props to the presentational components that it wraps. Here is an example of a container component that wraps a presentational component and provides it with data from the Redux store. Import connect from React Redux, import presentational component from /presentational component, function map state to props, state, return todos, state.todos. Function map dispatch to props, dispatch, return add todo, text, equals dispatch, add todo, text, remove todo, id, equals dispatch, remove todo, id, const container component equals connect, map state to props. Map dispatch to props, presentational component, export default container component. In this example, the map state to props function is used to specify which data from the Redux store should be provided to the presentational component as props. The map dispatch to props function is used to bind the action creators to dispatch, so that they can be called directly from the component's props. The connect function is then used to create a container component that wraps the presentational component and provides it with the appropriate data and actions. In Redux, map dispatch to props is a function that is used to bind action creators to the dispatch function. This allows the action creators to be called directly from the props of a component, rather than having to dispatch the actions manually. Here is an example of map dispatch to props being used to bind action creators to dispatch. Function map dispatch to props, dispatch, return add todo, text, equals dispatch, add todo, text, remove todo, id, equals dispatch, remove todo, id. In this example, the add todo and remove todo action creators are being bound to dispatch, so that they can be called directly from the component's props. For instance, a component could call this.props.addTodo, learn Redux, to dispatch the add todo action with the text value of learn Redux. Map dispatch to props is often used together with the connect function from the React Redux library, which is used to create container components that are connected to the Redux store. The connect function takes map dispatch to props as an argument, along with the component that it should wrap, and returns a new container component that is connected to the Redux store. To add multiple middlewares to a Redux store, you can use the apply middleware method from the Redux library. Apply middleware takes an array of middleware functions as an argument, and returns a store enhancer that can be passed to the create store function when creating the Redux store. Here is an example of using apply middleware to add multiple middlewares to a Redux store. Import create store. Apply middleware from Redux. Import thunk from Redux thunk. Import logger from Redux logger. Const store equals create store. Reducer. Apply middleware. Thunk. Logger. In this example, the thunk and logger middlewares are added to the Redux store using the apply middleware method. The apply middleware method returns a store enhancer, which is passed to the create store function when creating the store. This ensures that the thunk and logger middlewares will be applied to the store. Note that the order of the middleware functions in the array passed to apply middleware matters, as the middlewares will be applied to the store in the order they are specified. Redux form library. Which configuration would I use if I wanted to populate my form's initial values with data fetched from a remote endpoint? If you want to populate your form's initial values with data fetched from a remote endpoint using the Redux form library, you can use the initial values property in the configuration object passed to the Redux form higher order component. Here is an example of using the initial values property to populate the form's initial values with data fetched from a remote endpoint. Import Redux form from Redux form. Const myForm equals props equals / form component implementation. Const fetch initial values equals async equals / fetch data from remote endpoint. Return / return the initial values as an object. Const myForm with data equals Redux form myForm initial values fetch initial values myForm. In this example, the fetch initial values function is used to fetch the initial values for the form from a remote endpoint. The Redux form higher
Fuck,
order
I just
component is
realized
used to
that.
wrap the myForm component.
Just realized that I didn't increase the volume.
The Redux form higher order component is then used to wrap the myForm component, and the initial values property is set to the fetch initial values function. This causes the fetch initial values function to be called when the form is initialized, and the returned initial values to be used to populate the form. Note that the initial values property can be either a plain object or a function that returns a plain object. If it is a function, the function will be called with the current state and props of the form component, and the returned object will be used as the initial values for the form. To retrieve data from an API and populate the Redux state in a React application, you can use the Redux thunk middleware in the Axios library to make the API call and dispatch an action to update the state. Here is an example of retrieving data from an API and updating the Redux state. Import Axios from Axios. Import get data success. Get data error from /actions. Const get data equals return dispatch equals axios.get https //myapi.com/data then response equals dispatch get data success response.data catch error equals dispatch get data error. In this example, the getData function is an action creator that uses the Axios library to make an API call to retrieve the data. If the API call is successful, the getData success action is dispatched with the data as the payload. If the API call fails, the getData error action is dispatched with the error as the payload. To use this action creator, you would first need to apply the Redux thunk middleware to the Redux store. Then, you can dispatch the getData action from a component to make the API call and update the state. Import getData from /actions. Class myComponent extends React.component component did mount this.props.dispatch getData. / component implementation. Const map state to props equals state equals / map state to props. Export default connect map state to props my component. In this example, the myComponent component dispatches the getData action when it is mounted, which makes the API call and updates the state with the retrieved data. The component is connected to the Redux store using the connect function from the React Redux library, and the map state to props function is used to specify which data from the state should be provided as props to the component. The data flow sequence of the Flux concept is as follows. A user interacts with a view, such as by clicking on a button or entering some text in a form. The view dispatches an action, which is a plain object that describes the change. The dispatcher receives the action and broadcasts it to all the registered stores. The stores that are interested in the action receive the action and update their internal state accordingly. The stores emit a change event, which signals that their internal state has changed. The views that are listening for the change event receive the event and update themselves to reflect the new state. In this sequence, the data flows in a unidirectional loop, from the view through the dispatcher and stores, and back to the view. This allows for a predictable and maintainable application architecture. Free research preview.
Yeah. I also forgot to put the timer here, so I think I'm gonna do 1 hour, then take a break. Maybe I'll go for 1 hour and 15 minutes after. I think out of all of the things that I have there, the one that is gonna take the most time is the Rust. The other ones I think I took a look and they are not that big. Also, Vue.js is a big file as well. But maybe I won't be able to finish today because I think it's gonna take about 6 or 7 hours, something like that, to finish all of them on average.
Redux Dynamic Modules is a library that allows developers to split their Redux application into separate modules that can be loaded and unloaded at runtime. This makes it easier to manage the code for large Redux applications, as well as to implement features such as code splitting, which can improve the performance of the app by only loading the code that is needed at a given time. Redux Dynamic Modules is built on top of the Redux library and is fully compatible with it, so developers can use the familiar Redux APIs and patterns when using this library. A callback is a function that is passed as an argument to another function and is executed after the outer function has completed. This allows the outer function to perform some task and then pass control back to the caller by calling the callback function. One common use of callbacks is to handle asynchronous operations, such as fetching data from a server. In this case, the outer function would initiate the asynchronous operation, and the callback function would be called once the operation has completed, allowing the caller to handle the results of the operation. Another use of callbacks is to pass control flow between different parts of a program. For example, a callback function could be used to handle an event, such as a user clicking a button, and then pass control back to the main program to perform some action based on the event. Callbacks can have various effects on a program, depending on how they are used. One potential effect is that they can make code more difficult to read and understand, especially if the callbacks are nested or are used in complex ways. Additionally, using callbacks can make it more difficult to reason about the control flow of a program, since the order in which the callbacks are executed may not be clear. However, when used appropriately, callbacks can also make code more modular and reusable, as well as allowing for the implementation of complex logic and control flow. It is generally not considered good practice to create multiple store instances in a Redux application. This is because Redux is designed to work with a single store that holds the complete application state. Having multiple store instances can make it difficult to manage the state of the application, as well as making it more difficult to implement features such as time travel debugging and hot reloading. Instead of creating multiple store instances, it is better to use reducer composition to split the application state into separate pieces, each managed by its own reducer. This allows the application to have a single store instance, but still have a well-structured and modular state management system. This approach also makes it easier to test and debug the application, as well as making it easier to add or remove features from the application without affecting the rest of the code. In Redux, when data is spread across multiple reducers, each reducer manages a separate piece of the application state. This is known as reducer composition. The Redux store holds the complete application state, which is an object containing the state managed by each reducer. Reducer composition allows for a modular and scalable state management system, as it allows developers to split the application state into smaller, more manageable pieces. This also makes it easier to test and debug the application, as well as making it easier to add or remove features from the application without affecting the rest of the code. To implement reducer composition, the Redux store is created using the combine reducers function, which takes an object mapping the keys in the state object to the corresponding reducer functions. When an action is dispatched, each reducer is called with the current state for the part of the state that it manages, and it returns the new state for that part of the state. The combine reducers function then combines the new states from each reducer into a single state object, which is passed to the Redux store. Redux Thunk is a middleware for Redux that allows developers to write action creators that return a function instead of an action object. This function, known as a thunk, can be used to perform asynchronous operations, such as dispatching other actions or calling an API. Redux Thunk provides a simple and flexible way to handle asynchronous logic in a Redux application. To use Redux Thunk, it must be installed and added to the Redux store using the apply middleware function. Once it is added, action creators can return a thunk instead of an action object. The thunk will be called with the dispatch and get state functions from the Redux store, allowing it to dispatch actions and access the current state of the application. This makes it easy to perform asynchronous operations and update the application state in response to those operations. Redux Thunk is a popular choice for handling asynchronous logic in Redux applications, but it is not the only option. Other libraries, such as Redux Saga and Redux Observable, provide alternative approaches for managing asynchronous logic in a Redux application. Redux Persist is a library that allows a Redux application to persist its state to storage, such as to the local storage of a web browser or to a file on a device. This makes it possible for the application to retain its state even when the user closes the app or refreshes the page. To use Redux Persist, it must be installed and added to the Redux store. Once it is added, the developer can specify which parts of the state should be persisted, as well as the storage mechanism to use. When the application is started, Redux Persist will automatically load the persisted state into the Redux store, allowing the application to continue from where it left off. Redux Persist also provides tools for migrating the persisted state when the application state changes. This is useful when the application is updated and the structure of the state changes, as it allows the persisted state to be automatically updated to match the new structure. This can help prevent errors and maintain the integrity of the persisted state. Redux Saga is a middleware for Redux that allows developers to write complex asynchronous logic in a more readable and maintainable way. It uses an ES6 feature called generator functions to make it easier to work with asynchronous code, and provides a powerful API for handling asynchronous effects in a Redux application. To use Redux Saga, it must be installed and added to the Redux store using the apply middleware function. Once it is added, the developer can write sagas, which are generator functions that yield objects called effects. These effects describe asynchronous operations, such as calling an API or dispatching actions, and Redux Saga takes care of executing them and handling any errors that may occur. This allows the developer to write asynchronous logic in a more declarative way, making it easier to read and understand. Redux Saga provides many other useful features, such as the ability to cancel effects, to group related effects together, and to compose sagas to create more complex asynchronous logic. It is a popular choice for handling asynchronous logic in Redux applications, but it is not the only option. Other libraries, such as Redux Thunk and Redux Observable, provide alternative approaches for managing asynchronous logic in a Redux application. Free research preview, ChatGPT is optimized for dialogue.
I already know a lot of this, but I'm gonna do them anyway. think it's gonna say the get method. Some of these I don't know. Actually, this one. The Rust one, I think it will be interesting. I think on the Rust one, I'm gonna ask the difference between, I think it's implementation. I remember there was a question that I had some time ago that I couldn't quite understand it. So I'm gonna have to I think I'm gonna search on YouTube. I'm gonna search on YouTube again, and then once I see the videos that I saw before, I'm gonna know what is the question. But there was something that was really difficult for me to find a good video explaining. I think I'm gonna ask that question on the Rust one. It's gonna be interesting to see what the responses are like. I think I'm gonna have to close the thing there so that the light doesn't reflect, because I can barely see the cursor on the second monitor.
A contract is not necessarily needed between a server and a client in the context of a REST API. A REST API defines a set of architectural principles that dictate how web services should interact with each other. The principles of REST, such as statelessness and the use of HTTP methods, provide a framework for communication between clients and servers without the need for a contract. REST, or representational state transfer, is a set of architectural principles for designing web services. In the context of REST, a service is considered stateless if it does not maintain any information about the state of the client between requests. This means that each request from a client must include all of the information necessary for the server to understand and process the request, without relying on any information from previous requests. REST APIs typically support the following HTTP methods. GET, used to retrieve information from the server. This is the most common method and is used to retrieve information about a resource without modifying it. POST, used to submit data to the server for processing. This is typically used to create a new resource. PUT, used to update an existing resource on the server. DELETE, used to delete a resource from the server. Some REST APIs may also support other HTTP methods, such as patch and options. These methods are typically used for more specific purposes, such as updating only a part of a resource or checking the options available for a resource. The PUT and POST methods are both used to submit data to a server, but they differ in the way they handle the submitted data and the effect they have on the server. PUT is used to update an existing resource on the server. When you use PUT, you are replacing the current version of the resource with the data you are submitting. This means that if the resource does not exist on the server, PUT will create it. If the resource already exists, PUT will completely overwrite it with the new data. POST is used to submit data to the server for processing. Unlike PUT, POST does not replace the current version of a resource. Instead, it is used to create a new resource or to update a resource in a more flexible way than PUT allows. For example, POST can be used to add a new item to a collection or to update only part of a resource. In summary, PUT is used to update an existing resource, while POST is used to create a new resource or to update a resource in a more flexible way. To migrate from a SOAP-based system to a REST-based system, you will need to take the following steps. Identify the resources that your SOAP-based system provides, such as databases, files, or services. Design a set of endpoints, URLs, that will be used to access each of these resources, using the principles of REST. Implement these endpoints using a web framework or library that supports REST, such as Flask or Django. Create a web service that can handle HTTP requests and responses, and map these requests and responses to the appropriate resource. Test your web service to ensure that it is working correctly and is able to handle all of the different types of requests that your clients will make. The main difference between SOAP and REST is that SOAP is a protocol for exchanging structured and typed information, while REST is an architectural style for designing web services. SOAP uses XML to encode its messages, while REST uses simple HTTP messages to communicate. SOAP services are typically accessed using a specific SOAP client, while REST services can be accessed using any HTTP client. SOAP services also have strict rules for the format of their messages, while REST services have more flexibility in the way they structure their messages. JWT, or JSON Web Tokens, is a standard for encoding data in a JSON object and signing it with a digital signature. JWT is often used to securely transmit information between parties, such as an authentication token or other sensitive data. JWT is not typically used to encrypt data, as it is designed to be a compact and self-contained way of representing information. If you need to encrypt data, you should consider using a different mechanism, such as encrypting the data with a symmetric or asymmetric key before encoding it in a JWT. This will ensure that the data is protected from unauthorized access or modification while it is being transmitted. So, JWT is not used for encryption, but it can be used for signing the data. Best ways to scale with multiple nodes. Best solution. There are several ways to scale a web application across multiple nodes in order to improve its performance and availability. Some common approaches include load balancing. This involves distributing incoming requests across multiple nodes, so that each node only has to handle a portion of the total workload. This can help to ensure that the application remains responsive and can handle a large number of concurrent users. Caching. Caching is a technique that stores frequently accessed data in memory, so that it can be retrieved quickly without having to access the database or other data store. This can help to reduce the load on the database and improve the performance of the application. Microservices. Microservices is an architectural approach that involves breaking down a large application into smaller, independent components that can be deployed and scaled separately. This can make it easier to manage and scale the application, as well as allowing different parts of the application to be developed and maintained by different teams. As for storing and managing sessions after authentication, one common solution is to use a distributed cache, such as Redux or MEMC8. This allows session information to be stored in memory on multiple nodes, so that it can be accessed quickly and efficiently without having to rely on a single server or database. This can help to improve the performance and scalability of the application. Caching is a technique that is often used in the context of APIs to improve the performance and scalability of the application. When an API receives a request, it may need to fetch data from a database or other data store in order to fulfill the request. This can be time-consuming, especially if the data store is remote or if the request requires complex processing. By using a cache, the API can store the results of these requests in memory, so that they can be retrieved quickly the next time the same request is made. This can help to reduce the load on the database and other data stores, as well as improving the overall performance of the API. There are different ways to implement caching for an API, depending on the specific requirements of the application. For example, the API might use an in-memory cache, such as Redux or MEMC8, to store the results of requests. Alternatively, the API might use a cache that is integrated into the web server, such as the caching functionality provided by Hinks. In summary, caching can be an effective way to improve the performance and scalability of an API by reducing the load on the underlying data stores and speeding up the processing of requests. One way to secure an API using the cache control header is to specify that the API should not be cached by the client. This can be done by setting the cache control header to no cache or no store. This will instruct the client not to cache the API's responses, which will help to ensure that sensitive data is not stored on the client's device and is not accessible to unauthorized users. Another approach is to specify a short cache expiration time for the API's responses. This can be done by setting the cache control header to max age equals, where is the number of seconds that the response should be cached for. This will allow the client to cache the API's responses, but will also ensure that the cache is regularly updated with the latest data from the server. In summary, the cache control header can be used to secure an API by controlling how the API's responses are cached by the client. By specifying no cache or no store, or by setting a short expiration time, you can help to ensure that sensitive data is not stored on the client's device and is not accessible to unauthorized users. There are several rules that you should follow when creating a standard URI for a web service. Use a hierarchical structure. The URI should be organized into a hierarchy of resources, with each level of the hierarchy representing a different aspect of the service. For example, a URI for an online store might have the following structure: http://www.example.com/store/products/1. Use a consistent naming convention. The names of the resources in the URI should be consistent and intuitive, so that they are easy to understand and remember. For example, a URI for a product in an online store might use the product's name or ID as the resource name, rather than a random string of characters. Use lowercase letters. The URI should use lowercase letters for all of its components, including the scheme, e.g. HTTP, the host name, e.g. www.example.com, and this will help to ensure that the URI is easy to read and interpret. Avoid using special characters. The URI should not contain any special characters, such as spaces, punctuation, or non-ASCII characters. These characters can cause problems when the URI is used in different contexts, such as when it is passed as a parameter to a web service or when it is used in a URL. Use a // to separate the different levels of the hierarchy. The URI should use a // to separate the different levels of the hierarchy. This will help to make the URI more readable and will make it easier to navigate between different levels of the hierarchy. In summary, a standard URI for a web service should be organized into a hierarchy of resources, use a consistent naming convention, use lowercase letters, avoid special characters, and use a / to separate the different levels of the hierarchy. By following these rules, you can create URIs that are easy to understand and use, and that will help to make your web service more accessible and user-friendly. The content type header is an HTTP header that is used to indicate the media type of the request or response body. This header is used to specify the format of the data that is being transmitted, such as whether it is plain text, HTML, XML, or some other format. The content type header is typically included in the HTTP request or response headers, along with other headers such as accept, content encoding, and content language. The value of the content type header is usually a MIME type, which is a standardized format for specifying the type and format of a media resource. Some common examples of MIME types include text/plain, text/HTML, and application/JSON. In summary, the content type header is used to specify the media type of the request or response body, and is typically included in the HTTP request or response headers. This header is important because it allows the client and server to agree on the format of the data that is being transmitted, which is essential for successful communication between the two parties. An HTTP request is a message that is sent from a client to a server to request information or to perform an action. An HTTP request consists of several components, including the following. The request method. This specifies the type of action that the request is asking the server to perform, such as get, post, put, or delete. The request URI. This specifies the location of the resource that the request is asking the server to access or modify. The URI is typically a combination of the server's host name and the path to the resource on the server. The request headers, these are a set of key value pairs that provide additional information about the request, such as the type and format of the data being sent, the client's preferred language, and the cookies that the client has stored. The request body, this is the optional part of the request that contains the data that the client is sending to the server. The request body is only used for certain types of requests, such as POST or PUT, and is typically used to submit data to the server for processing or storage. In summary, the core components of an HTTP request are the request method, the request URI, the request headers, and the request body. These components are used to specify the action that the client is asking the server to perform, the location of the resource that the request is targeting, and any additional information or data that is needed to complete the request. There are several ways to make a system only accept one session at a time. Some common approaches include using a token-based authentication system. In this approach, the system will generate a unique token for each user when they log in. The token will be sent to the user, and the user will need to include the token in all subsequent requests to the system. The system will then only accept requests that include a valid token. This will ensure that only one user can be logged in at a time, as each user will have their own unique token. Limiting the number of concurrent sessions. Another approach is to limit the number of concurrent sessions that a user can have. For example, the system might allow each user to have only one active session at a time. If a user tries to log in from a different device or location, their previous session will be terminated and their new session will be activated. This will ensure that only one session is active for each user at any given time. Implementing a single sign-on system. A single sign-on (SSO) system allows users to log into multiple applications using a single set of credentials. This can be a convenient way to manage user access, but it also means that if a user logs into one application, they will be automatically logged out of all other applications that are part of the SSO system. This will ensure that only one session is active for each user at any given time. In summary, there are several ways to make a system only accept one session at a time, including using a token-based authentication system, limiting the number of concurrent sessions, and implementing a single sign-on system. The GetHTTP method is considered the safest and most read-only method, as it is used to retrieve information from the server without modifying any data. The GET method does not have any side effects, meaning that it does not change the state of the server or the data it is serving. This makes GET requests idempotent, which means that they can be repeated multiple times without causing any changes to the server or the data. In contrast, other HTTP methods, such as POST, PUT, and DELETE, are typically used to modify data on the server. These methods can have side effects, such as creating, updating, or deleting data, and are therefore not idempotent. This means that they should be used with caution, and only when it is appropriate to modify data on the server. In summary, the GetHTTP method is considered the safest and most read-only method, as it is used to retrieve information from the server without modifying any data. Other HTTP methods, such as POST, PUT, and DELETE, are typically used to modify data on the server, and should be used with caution. There is no fixed upper limit for the payload size in REST. The size of the payload, or the amount of data that can be transmitted in a single request or response, will depend on several factors, such as the capabilities of the client and server, the network infrastructure, and the specific implementation of the REST API. In general, REST APIs are designed to be flexible and scalable, and are not intended to impose arbitrary limits on the size of the payload. However, some REST APIs may have specific limits on the size of the payload in order to protect the server from being overwhelmed by excessively large requests. In addition, some HTTP servers and clients may have built-in limitations on the size of the payload that they can handle. For example, some servers may have a maximum request size that they will accept, while some clients may have a maximum response size that they can process. These limitations will vary depending on the specific implementation of the server or client, and may need to be taken into account when designing and implementing a REST API. In summary, there is no fixed upper limit for the payload size in REST. The size of the payload will depend on a variety of factors, and may be subject to specific limitations in the server, client, or network infrastructure. Free research.
Oh, I think was traits. Traits and types, something like that. Yeah, I think was traits and implements. The difference between traits and implements. I remember the video with this thumbnail here when I was searching for. So I'm gonna ask that question. But I'm gonna ask after I go through all of this. All of the ones that I have here. I think I'm gonna do less of them by round because otherwise I think it gets too long. I think 20 minutes is too long for one text-to-speech thing. I think around 15 minutes or 12 minutes should be better. So I think I'm gonna do this one, then this, until I get to the red here, and then I'm gonna do the text-to-speech again. Yeah, I'm gonna put this one. I just realized that it's not as big as I thought it would be, because I have the notes there that I wrote. But I'm gonna put this one here to see if it's correct or not. Yeah. Okay, so I have to stop on this.
In Rust, memory on the heap is cleaned up automatically through a mechanism called automatic reference counting, ARC. When an object is no longer needed, the Rust compiler will automatically deallocate the memory and free it up for use by other parts of the program. This process is automatic and doesn't require any explicit action on the part of the programmer. Scalar types.
On the heap is cleaned up automatically.
In Rust, memory on the heap is cleaned up automatically through a mechanism called automatic reference counting, ARC. When an object is no longer needed, the Rust compiler will automatically deallocate the memory and free it up for use by other parts of the program. This process is automatic and doesn't require any explicit action on the part of the programmer. Scalar types, integers, signed numbers, boolean. In Rust, the scalar types are the most basic types and include integers, floating point numbers, booleans, and characters. Integers are whole numbers that can be either signed or unsigned, depending on whether they can represent negative or only positive values. Rust has several built-in integer types, including i8, i16, i32, and i64 for signed integers and u8, u16, u32, and u64 for unsigned integers. Floating point numbers are numbers with decimal points and are represented by the f32 and f64 types in Rust. Booleans are a simple data type that can only have one of two possible values, true or false. Characters in Rust are represented by the char type and are a single Unicode code point. In addition to these basic scalar types, Rust also has support for compound types, such as arrays and tuples, which can group multiple values together into a single type. In Rust, a tuple is a compound data type that groups together multiple values of potentially different types into a single type. Tuples are often used to return multiple values from a function or to pass multiple arguments to a function. To create a tuple, you simply enclose the values you want to include in the tuple within parentheses and separate them with commas. For example, to create a tuple that contains an i32 integer in a char, you could write the following code. Let mytuple equals 5. To access the values in a tuple, you can use pattern matching to destructure the tuple into individual variables. For example, to destructure the mytuple tuple from the previous example into two variables, you could write the following code. Let x, y equals mytuple. This code will bind the first value in the tuple to the x variable and the second value to the y variable. You can then use these variables like any other variables in your code. It's also possible to initialize a tuple directly, without using pattern matching, by simply providing the values you want to include in the tuple as separate arguments to the tuple type. For example, to create the mytuple tuple from the previous examples, you could write the following code. Let mytuple, i32. This code explicitly specifies the types of the values in the tuple, an i32 integer in a char, and then provides the values as separate arguments to the tuple type. This allows you to create a tuple without using pattern matching. In Rust, not all types are automatically copyable. This means that when you assign a value of that type to a new variable, or pass it to a function as an argument, the value is not automatically copied. Instead, the original value is moved to the new location and the old location is invalidated. Some examples of types that are not automatically copyable in Rust are the char type, which represents a single Unicode code point. The bool type, which represents a Boolean value, true or false. Tuples that contain at least one non-copyable type, such as i32, or i32, string. When working with types that are not automatically copyable, you need to be careful to avoid invalidating the original value. For example, if you try to assign a value of a non-copyable type to two different variables, the original value will be moved to the first variable and the second variable will be left uninitialized. Let x equals 5, let y equals x, /x is still valid, let s1 equals string from, hello, let s2 equals s1, /s1 is now invalid. In the code above, the x variable is a copyable type, an i32 integer, so when we assign it to the y variable, the value is copied and both x and y are valid. However, the s1 variable is a non-copyable type, a string, so when we assign it to the s2 variable, the value is moved and s1 is now invalid. To avoid invalidating the original value when working with non-copyable types, you can use the clone method to make a deep copy of the value. This will create a new value with the same contents as the original, allowing you to use the original value and the new value independently. Let x equals 5, let y equals x.clone, /x is still valid, let s1 equals string from, hello, let s2 equals s1.clone, /s1 is still valid. In the code above, we use the clone method to create a deep copy of the x and s1 values, allowing us to use the original values and the new values independently without invalidating the original values. In Rust, the primitive compound types are the tuple and the array. A tuple is a fixed-size collection of values of potentially different types. Tuples are often used to return multiple values from a function or to pass multiple arguments to a function. For example, you could create a tuple that contains an i32 integer in a string like this. Let mytuple equals 5, string from, hello. An array is a fixed-size collection of values of the same type. Arrays are often used to store a sequence of values that need to be accessed by their index. For example, you could create an array of i32 integers like this. Let myArray equals 1, 2, 3, 4, 5. Rust does not have built-in support for other compound data types such as lists or maps. However, there are many third-party libraries that provide these data types and other more advanced data structures. These libraries can be easily integrated into a Rust project using the Cargo Package Manager. Free research preview. Rust, use of unit-like structs, useful for generics, if you don't want to store in the type itself, behave similar to. In Rust, it is common to use unit-like structs as a placeholder when using generics. This is useful when you don't want to store any data in the type itself, but still need to specify a type in a generic context. Unit-like structs are structs that have no fields and behave similarly to the unit type. They are often used in generic contexts where the type being used doesn't matter and is only being used to fill a type requirement. Here is an example of using a unit-like struct as a generic parameter. Struct my struct / some fields here, impl my struct fn new, dash my struct / implementation goes here, / we use the unit-like struct empty as a placeholder for the generic type t let mistruct, my struct equals my struct new. In this example, the my struct has a generic type parameter t. The my struct new method is implemented for any type t, and returns a new instance of my struct. When we create an instance of my struct, we use the empty unit-like struct as a placeholder for the generic type t. This allows us to create an instance of my struct without specifying a concrete type for the generic parameter. Automatic reference counting, ARC, is a system used in some programming languages, such as Rust and Swift, to manage the memory allocation and deallocation of objects. ARC works by keeping track of the number of references to a particular object in memory. When a new reference to an object is created, the reference count is incremented. When a reference goes out of scope or is otherwise no longer needed, the reference count is decremented. When the reference count reaches 0, the object is automatically deallocated and its memory is freed. One of the advantages of using ARC is that it allows for simple, safe memory management in a language without garbage collection. This can lead to better performance, as the programmer has more control over when memory is allocated and freed. ARC is also easier to reason about than other memory management systems, such as manual memory management or garbage collection. This is because the programmer does not need to worry about explicitly deallocating memory or dealing with memory leaks. The ARC system takes care of these tasks automatically. Overall, ARC is a useful tool for managing memory in a safe and efficient manner, and can be a valuable addition to a programming language's feature set. Valid rules for references must always be valid. One mutable reference. The compiler guarantees that there are several rules that apply to references in Rust. A reference must always be valid. In other words, it must always refer to a valid object in memory. There can only be one mutable reference to a particular piece of data in a given scope. This rule is in place to prevent data races and other synchronization issues. The Rust compiler guarantees that references will never be dangling references. A dangling reference is a reference to an object that no longer exists. In Rust, the compiler will prevent the creation of dangling references through a combination of static analysis and runtime checks. Immutable references are not to be used after mutable references to the same data have been dropped. This rule is in place to prevent data races and other synchronization issues. These rules are designed to ensure that references are used safely and efficiently in Rust. By following these rules, you can avoid common pitfalls and bugs that can arise when using references in your code. In Rust, the string data type holds a pointer to a chunk of
Let me stop a little bit to think about this for a sec. It can only be one mutable reference to a particular piece of data in a given scope. Prevent data races and other synchronization issues. Okay, so if I declare a variable, I can only reference to that variable once on that scope. This is what this is saying. Okay, and I understand, because if you reference twice, then there might be problems of the access of both variables trying to access the same value at the same time. Okay, got it.
In Rust, the string data type holds a pointer to a chunk of memory that contains the string value, as well as the length and capacity of the string. The length of a string is the number of characters it contains, while the capacity is the total amount of memory allocated for the string. The capacity is usually larger than the length, as it includes extra memory to allow the string to grow without needing to be reallocated in memory. The string value itself is stored in a contiguous chunk of memory pointed to by the string object. This chunk of memory contains the individual characters of the string, as well as a null terminator to indicate the end of the string. In summary, a string in Rust holds a pointer to a chunk of memory that contains the string value, as well as the length and capacity of the string. This allows the string to manage its own memory efficiently and provide a convenient and safe way to work with string data in Rust. Associated functions, defining functions within methods, associated with structs, return a new instance of the struct, can be used for constructors. In Rust, associated functions are functions that are defined within methods and are associated with a particular struct. These functions are not associated with a particular instance of the struct, but rather with the struct itself. Associated functions are often used to provide a convenient way to create a new instance of a struct. For example, the string struct in Rust has an associated function called new, that creates a new, empty string object. Let s equals string new. In this example, we use the new, associated function to create a new string object, which we then store in the s variable. It is important to note that associated functions cannot be used as constructors for a struct. In other words, you cannot use an associated function to initialize a new instance of a struct with specific values. Instead, you must use the regular constructor syntax, struct name field 1, value 1, field 2, value 2, to create a new instance of a struct with specific values. In summary, associated functions are functions that are defined within methods and are associated with a particular struct. These functions provide a convenient way to create a new instance of the struct, but cannot be used as constructors. In Rust, constants can be defined in the global scope, the local scope, and within methods. However, constants cannot be defined within functions. To define a constant in the global scope, you can use the const keyword followed by the constant's name, type, and value. For example, const pi, f64 equals 3.141592. This defines a constant named pi of type f64 with the value 3.141592. To define a constant in the local scope, you can use the let keyword with the const keyword. For example, let x equals 5, let y equals 6, const sum, i32 equals x plus y. This defines a constant named sum of type i32 with the value 11. The value of the constant is the sum of the values of the x and y variables. To define a constant within a method, you can use the same syntax as in the local scope. For example, implement struct f and my method, let x equals 5, let y equals 6, const sum, i32 equals x plus y. In this example, the my method defines a constant named sum of type i32 with the value 11. In summary, constants can be defined in the global, local, and method scopes in Rust, but cannot be defined within functions. When data race occurs, two or more pointers access the same data at the same time, at least one of the pointers is being used to write to the data, there's no mechanism being used to synchronize access to the data. A data race occurs in Rust when two or more pointers access the same data at the same time, and at least one of the pointers is being used to write to the data. This can lead to unpredictable behavior and can even cause the program to crash. Data races are a common source of bugs in concurrent and parallel programs. In order to avoid data races, it is important to use synchronization mechanisms, such as mutexes or atomic reference counting, to ensure that access to shared data is properly coordinated. Here is an example of a data race in Rust. Use std-sync arc, use std-thread, let data equals arc new, vec, 1, 2, 3, for I in 03 let data equals data.clone, thread spawn, move data I plus equals 1. In this example, we are creating 3 threads that each access and modify the same data vector. Because the data vector is shared between the threads and is being modified by multiple threads, this code will likely cause a data race. To avoid the data race, we can use a mutex to synchronize access to the data vector. A mutex is a synchronization primitive that allows only one thread to access the data at a time. Here is an example of using a mutex to avoid a data race. Use std-sync arc, mutex, use std-thread, let data equals arc new, mutex new, vec, 1, 2, 3, for I in 03 let data equals data.clone, thread spawn, move let mud data equals data.lock, .unwrap, data I plus equals 1. In this example, we are using a mutex to synchronize access to the data vector. This ensures that only one thread can access the data at a time, preventing a data race. In summary, a data race occurs in Rust when two or more pointers access the same data at the same time, and at least one of the pointers is being used to write to the data. To avoid data races, it is important to use synchronization mechanisms, such as mutexes, to coordinate access to shared data. Automatic copying, inexpensive in terms of runtime performance. Automatic copying refers to the behavior of some programming languages, such as Rust, where objects are automatically copied when they are assigned to new variables or passed as arguments to functions. This can be useful because it is often inexpensive in terms of runtime performance. However, automatic copying can also hinder runtime performance in some cases. This is because creating deep copies of data can be expensive, especially for large or complex data structures. In these cases, it may be more efficient to use reference counting or other mechanisms to avoid unnecessary copying. Here is an example of automatic copying in Rust. Let x equals 5, let y equals x, // x is automatically copied when assigned to y println, x equals, x, // prints, x equals 5, println, y equals, y, // prints, y equals 5, y plus equals 1, println, x equals, x, // prints, x equals 5, println, y equals, y, // prints, y equals 6. In this example, the value of the x variable is automatically copied when it is assigned to the y variable. This means that x and y have different memory addresses, and modifying y does not affect the value of x. However, if we were working with a large or complex data structure, this automatic copying behavior could hinder runtime performance. In these cases, it may be more efficient to use reference counting or other mechanisms to avoid unnecessary copying. In summary, automatic copying is a useful feature of some programming languages, but can hinder runtime performance in some cases. To avoid these performance issues, it may be necessary to use reference counting or other mechanisms to avoid unnecessary copying of data.
I think I have several questions on this one that I don't have it here and I want to ask. But I think I'm gonna have to just continue to do the stuff until I finish all the files that I have. because I don't want to risk spending too much time on Rust and then not finishing the other files. So I think I'll go back to Rust at some point. Oh, actually, yeah, the only question that I'm gonna ask that is the one that's from the video there, but I also have other types of questions like macros. It looks like this one has macros. I want to ask, what are the advanced concepts in Rust and what is the best way to learn them? Something like that. And then make a list and then see if you can give me any information to understand the concepts in a easy way. Fuck. So that was the end, and I thought there were still more inputs. Or outputs, I should say. I'll be right back. Okay, forgot about the timer. And I just remembered something, or just realized something that I can actually put it on the description of the live streams. And I don't know why I didn't think about that. That I'm not looking at the chat while I was streaming, so people don't think I'm gonna respond. So I'm gonna do that right now. And I'm also gonna put my Discord handle there, I think. I don't know if I can change. Okay. Where is my thing? Oh. I'm gonna see where you're trying to find out the number in the Discord of my hashtag. I think I'll see this later. Whatever. Yeah, okay. Looks like it worked. I think this will probably continue if I put there, but I don't think it matters, so I'm just gonna put the results, the next one. I think this one I'm gonna do in a different prompt. In a different thread.
In Rust, the result type is an enum that represents either a success value, OK, or an error value, error. Methods can be defined on the result type, just like any other type. One such method is expect, which is used to extract the success value from a result or to panic if the result is an error value. For example, let result equals OK, 42, let value equals result.expect, failed to extract value, / value is now 42, let result equals error message. Let value equals result.expect, failed to extract value, / this will cause a panic with the message, failed to extract value, error message. Another method is unwrap, which is similar to expect, but does not take a custom error message. Instead, it will use a default message when panicking. Another common pattern for working with result values is to use match to handle both the success and error cases explicitly. Let result equals OK, 42, match result OK, value, equals / do something with the success value error, message, equals / handle the error. Main is a special function in Rust that is the entry point of every Rust program. It is the first function that is called when the program is run. The main function is defined in the std main module. Fn main, / this is where the program starts execution. Rust does not have a init function. The init function you are referring to may be from a different programming language. In Rust, the new syntax is used to call a static method on a type. A static method is a method that is defined directly on the type itself, rather than on an instance of the type. Static methods can be called without creating an instance of the type. For example, struct point x, i32, y, i32, impl point fn new, x, i32, y, i32, -self / this is a static method that creates a new point instance self x. In Rust, it is not possible to define abstract methods. Rust does not support inheritance or polymorphism in the traditional object-oriented sense. Instead, Rust uses traits to provide a similar mechanism for abstraction. A trait is a collection of methods that define a set of behaviors that types can implement. Unlike abstract methods in other languages, a trait cannot be partially implemented. If a type implements a trait, it must implement all of the methods in the trait. Trait animal fn make sound, and self, -and, static str, struct cat, impl_animal for cat fn make sound, and self, -and, static str meow struct dog, impl_animal for dog fn make sound, and self, -and static str woof. Rust does not have a concept of final methods. In Rust, it is not possible to override a method in a child type. If you want to prevent a method from being overridden, you can make the method private. Struct base fn foo, and self, / do something struct derived fn foo, and self, // as mentioned earlier, in Rust the main function is the entry point of every Rust program. It is the first function that is called when the program is run. The main function is defined in the std main module. Fn main, / this is where in Rust, the continue keyword can be used in loops, for, while, loop, to skip the remaining code in the current iteration and move on to the next iteration. For example, for I in 010 if I %2 equals, in this code, the continue keyword is used with a label to skip to the next. In Rust, an enum is a type that can have a fixed set of values. Each value in an enum is called a variant. Enums can be used to represent a group of related variants. For example, the option enum is used to represent a value that can either be some value or none. Enum option some, t, none. A struct is a type that consists of a collection of named fields. Each field has a name and a type. Structs are used to define new types that represent a group of related data. For example, struct point x, i32, y, i32. A trait is a collection of methods that define a set of behaviors that types can implement. Traits are used to provide a common interface for related types. For example, the clone trait defines a clone method that types can implement to allow them to be cloned. Trait clone fn clone, and self, -self. A type is a classification of data that defines the operations that can be performed on that data. In Rust, every value has a type, and all operations are restricted to values of the correct type. Rust has several built-in types, such as i32 for signed 32-bit integers, and f64 for 64-bit floating point numbers. It also allows users to define their own types using enums, structs, and traits. In Rust, enums are used to define a fixed set of values that a variable can take. Enums can be useful when you want to represent a group of related values and give them a name. For example, the option enum is used to represent a value that can either be some value or none. Enum option some, t, none, let x, option equals some, 5. Structs are used to define new types that consist of a collection of named fields. Each field has a name and a type. Structs are useful when you want to group related data together and give it a name. For example, struct point x, i32, y, i32, let origin equals point x, 0, y, 0. Traits are used to define a common interface for related types. A trait defines a set of methods that types can implement to provide a consistent behavior. Traits are useful when you want to define a behavior that multiple types can implement. For example, the clone trait defines a clone method that types can implement to allow them to be cloned. Trait clone fn clone, and self, -self, impl clone for i32 fn clone, and self, -self asterisk self let x equals 5, let y equals x dot clone. In general, you should use enums when you want to define a fixed set of values that a variable can take. You should use structs when you want to group related data together and give it a name. And you should use traits when you want to define a common interface for related types. Rust macros are expanded into abstract syntax trees, rather than string. Yes, that is correct. In Rust, macros are expanded into abstract syntax trees, ASTs, rather than being pre-processed as strings. This means that the Rust compiler has full knowledge of the structure of the code generated by a macro, allowing it to perform more powerful and sophisticated transformations. The option type is an enum that represents a value that can either be some value or none. It is often used to represent the absence of a value. For example, enum option some, t, none, let x, option equals some, 5. The unwrap method can be used to extract the value from an option instance. It will return the value if the option is some, or it will panic if the option is none. For example, Let x, option equals sum, 5, let y equals x dot unwrap, / y is 5 let x, option equals none, let y equals x dot unwrap, / this will cause a panic. The expect method is similar to unwrap, but it allows you to provide a custom error message that will be used in the panic message. For example, let x, option equals sum, 5, let y equals x. In Rust, the result type is an enum that represents either a success value, OK, or an error value, error. It is often used to represent the result of a computation that may fail. For example, enum result OK, t, error. The result type is commonly used in Rust because it allows you to propagate errors through your code without having to use unwrap or expect, which can cause your program to panic. Instead, you can use match to handle the success and error cases explicitly. For example, let x, result equals OK, 5, match x OK, value, equals / do something with the success value error, message, equals / handle the error. Another common pattern for working with result values is to use the operator, which allows you to propagate the error value up the call stack without having to use match. For example, fn doso mething, result let x, result equals OK, 5, let y, result equals error message, / propagate the error up the call stack let result equals x plus y, OK, result. In this code, the operator is used to propagate the error value up the call stack if either x or y is an error value. Otherwise, it will extract the success value and perform the addition. In the Rust standard library, heap allocated pointers are represented by the box type. A box is a smart pointer that points to a value of type t allocated on the heap. It allows you to store values that are too large to fit on the stack, or values that have a non-fixed size. The box type implements the deref trait, which allows you to dereference the box as if it were a regular reference. This means you can use the asterisk operator to access the value pointed to by the box. For example, let x equals box new, 5, / dereference the box as if it were a regular reference let y equals *x. One of the main advantages of using a box instead of a regular reference is that it is owned by the caller and will be automatically deallocated when it goes out of scope. This eliminates the need to manually manage the lifetime and deallocation of the value. / allocate a value on the heap and create a box let x equals box new, 5, / do something with x / x is automatically deallocated when it goes out of scope. The box type is often used in combination with the box int or raw and box from raw methods to convert between a box and a raw pointer. This can be useful when interacting with FFI, foreign function interface, code that expects raw pointers. Let x equals box new, 5, / convert the box to a raw pointer let raw equals box int or raw, x, / do something with the raw pointer / convert the raw pointer back to a box let x equals unsafe box from raw. In this code, the box int or raw method is used to convert the box to a raw pointer, and the box from raw method is used to convert the raw pointer back to a box. Note that this code is marked as unsafe because it involves dereferencing raw pointers, which can be dangerous if not done correctly. Free research
Constraints and implements. I think I'll leave this file like this. Rust. Here. I think I'll try to do this one more and then I'm gonna stop. And then I'm gonna do the rest off stream, I think. There are still more questions that I wanna ask about Rust, but I'm gonna leave that for after I finish this stuff here. Oh, fuck. It's gonna say too many requests, I think. Yeah.
Rust, dereferencing makes the value point to the in Rust, dereferencing a pointer allows you to access the value that the pointer points to. Pointers in Rust are a way of storing the memory address of a value. When you have a pointer, you can use the asterisk operator to dereference the pointer and access the value that it points to. For example, if you have a pointer p that points to an integer value 5 in memory, you can dereference p and access the value using the following syntax. Let p, asterisk const I32 equals n5, let x equals asterisk p. In this code, p is a pointer to an integer value 5, and x is a variable that holds the value of 5. The asterisk operator is used to dereference the pointer and access the value that it points to. It's important to note that dereferencing a pointer can be a dangerous operation if the pointer is not valid. For example, if you try to dereference a null pointer, it can cause your program to crash. In Rust, the borrow checker helps prevent this by ensuring that pointers are always valid before they are dereferenced. Free research preview, ChatGPT is optimized for dialogue.
I think I'm gonna do this, some of this in the same thread. And then after I do, I think I'm gonna do 5 of this up until here, and then I'm gonna stop and do the rest off stream. Maybe this is a typo.
In the Rust programming language, traits, employees, and types are all important language features that enable programmers to define and use abstractions in their code. A trait is a collection of methods that can be implemented by a type. Traits define a common interface for types that implement them, which allows for code reuse and abstraction. For example, the iterator trait defines a number of methods that can be implemented by any type that represents an iterator, such as vec or linked list. An impl block is where you can provide implementations for traits or for a specific type. You can use impl blocks to implement a trait for a type, or to define methods on a type that aren't part of a trait. A type is a data type that represents the kind of value a variable or expression can have. Types can be primitive, like integers or booleans, or they can be defined by the programmer using struct, enum, or trait definitions. In summary, traits define common behavior that can be implemented by types. Impl blocks are where you provide implementations for traits or types, and a type is a data type that represents the kind of value a variable or expression can have.
Traits define common behavior that can be implemented by types. Implement. So if you have a type like an integer or linked list, so you can invent your own types, and then you can use the traits to define the behavior of the types. Implement blocks are where you provide implementations for traits or types. Implementation for traits or types. So what's the difference between implements? It's hard. I think I understand, but it's still hard for me to grasp the difference between implement and traits. So I'm gonna write this down so I can search later. Once I'm done with all the files, I'm gonna go deeper into this, or spend more time thinking about it. While I'm gonna probably use ChatGPT to try to understand better. Traits are types, and the types that data type that represents the kind of value a variable or expression can have. So because a trait can define the behavior. What is the difference between, what does it mean to define the behavior, the common behavior, and to provide implementations? Because how do you define the behavior? It's through functions, and implementations is functions as well. So, but maybe the difference is that implementations you can make it so that you have instances, and then with the trait you don't have. Yeah, because trait is like an abstract class. So I think I remember now. So yeah, trait is like the abstract class, so it's like the template for all, and then you're gonna have to implement all the functions inside of the trait every time you create something of that type, and then the implementation is just the instance of the class. And so I think I get it now, actually. So I don't need to search for this. But I'm gonna study more advanced Rust concepts, I think, after I'm done with all the files using ChatGPT. Maybe I'll do that tomorrow on stream. If I don't, yeah, if nothing else comes to mind to do it, because I still have to film the videos. Yes, it's gonna depend on what I do today, I think.
In summary, traits define common behavior that can be implemented by. In the socket.io library, socket.on is used to register a callback function that will be called when a particular event is emitted. This allows you to specify different behavior for different events. To remove a specific listener for an event, you can use the socket.off method. This method takes the event name and the callback function as arguments, and it will remove the callback from the list of listeners for that event. Alternatively, you can use the socket.once method to register a callback that will be called only the first time the specified event is emitted. This is useful if you only want to handle an event once, without having to explicitly remove the listener later. Finally, the socket.removeAllListeners method can be used to remove all listeners for a particular event, or for all events if no event name is specified. This can be useful for cleaning up your code and removing unnecessary event listeners. WebSockets is a protocol that provides full duplex communication channels over a single TCP connection. It allows for real-time communication between the client and server, and it is commonly used in applications like online gaming and chat services. In WebSockets, events are handled using the onMessage event handler on the WebSocket object. To remove a specific listener for this event, you can use the removeEventListener method, which takes the event name and the callback function as arguments. To remove all listeners for the onMessage event, you can use the removeAllEventListeners method. However, this method is not part of the official WebSockets specification, so it may not be available in all WebSockets implementations. I'm sorry, but I cannot provide information on a specific status code 5 as there is no standardized meaning for this code. HTTP status codes are 3-digit numbers that indicate the status of a response from a server to a client. The first digit of the status code defines the class of the response, with the most common status codes belonging to the classes 2xx, success, 3xx, redirection, 4xx, client error, and 5xx, server error. For example, the status code 200 indicates a successful request, while the status code 404 indicates that the requested resource was not found. However, there is no standardized status code 5xx, so the meaning of a status code with the first digit of 5 would depend on the specific server or application that is returning it. If you are encountering a status code 5xx in your application, it is best to refer to the documentation for the server or application that is returning the code to determine its meaning and how to handle it. The WebSocket protocol is a protocol for full duplex communication over a single TCP connection. It allows for bidirectional communication between the client and server, allowing messages to be sent and received in real time. The WebSocket protocol defines a number of rules that govern the way that clients and servers communicate. For example, it defines the format of the messages that are sent between the client and server, as well as the rules for establishing and maintaining the WebSocket connection. The UDP socket is a type of network socket that uses the User Datagram Protocol, UDP, to send and receive data. UDP is a connectionless protocol, which means that it does not establish a persistent connection between the client and server like TCP does. This makes UDP sockets well suited for applications that require low latency, real-time communication, such as video and audio streaming. A long-lived TCP socket, on the other hand, is a network socket that uses the Transmission Control Protocol, TCP, to send and receive data. TCP is a connection-oriented protocol, which means that it establishes a persistent connection between the client and server and ensures that all data is delivered reliably. This makes TCP sockets well suited for applications that require reliable data transfer, such as file transfer or email. A short-lived TCP socket, also known as an ephemeral socket, is a TCP socket that is opened and closed very quickly. This is common in applications that make many short-lived connections to a server, such as web browsers that download many small files from a web server. In summary, the WebSocket protocol defines rules for full duplex communication over a single TCP connection. UDP sockets use the connectionless UDP protocol for low-latency communication. And TCP sockets can be either long-lived or short-lived depending on the needs of the application. SockET.io is a JavaScript library that provides real-time, bidirectional communication between clients and servers. It allows for the creation of WebSockets that can be used to send and receive data in real time, making it well-suited for applications like online chat and gaming. The SockET.io library uses a variety of protocols to establish and maintain its WebSockets, depending on the capabilities of the client and server. By default, SockET.io will use WebSockets as the underlying protocol for its WebSockets, as this provides the best performance and lowest latency. If the client or server does not support WebSockets, SockET.io will automatically fall back to using other protocols, such as HTTP long polling or HTTP streaming, to provide real-time communication. These protocols are less efficient than WebSockets, but they can still provide bidirectional communication in most cases. SockET.io does not support UDP as a transport protocol for its WebSockets. This is because UDP is a connectionless protocol, which is not well suited for the bidirectional, real-time communication that SockET.io provides. In summary, the SockET.io library uses WebSockets as its default protocol for establishing and maintaining WebSockets, but it will fall back to using other protocols like HTTP long polling or HTTP streaming if WebSockets are not available. It does not support UDP as a transport protocol. SockET.io, how to add particular state to the browsing history, set state. In the SockET.io library, there is no built-in way to add a particular state to the browsing history. SockET.io is a library for real-time, bidirectional communication between clients and servers, and it is not directly related to the browser's history management. However, if you want to add a particular state to the browsing history, you can use the history module provided by the React Router library. This library provides a number of methods for managing the history of a React application, including push state, replace state, and set state. The push state method allows you to add a new entry to the browsing history, while replace state allows you to replace the current entry in the history with a new one. Both of these methods take the new state, the title of the new state, and the URL for the new state as arguments. The set state method, on the other hand, allows you to update the current state of the history without adding a new entry or replacing the existing one. This method takes a new state object as an argument, and it updates the current state in place. In summary, if you want to add a particular state to the browsing history in a SockET.io application, you can use the history module provided by the React Router library. This module provides methods like push state, replace state, and set state that allow you to manipulate the history of your application. To close a socket, you can use the close method of the socket object. This method takes no arguments and it immediately closes the socket. For example, if you have a socket object called socket, you can close it like this. Socket.close. Once a socket has been closed, it cannot be used again. Attempting to send or receive data over a closed socket will result in an error. It is important to properly close a socket when you are finished using it, as this frees up system resources and ensures that the underlying connection is properly terminated. Failure to close a socket can lead to resource leaks and other problems. Free research.
I'm gonna stop here. I'm probably gonna come back tomorrow. So yeah.